seen this in other meetings. What you say is sort of in the public space. So, as a reminder. So as on the agenda, we've got some updates, some current business, and basically a lot of discussion of sort of all business, I think is probably the better way to put this. And we have a questionnaire that we're sort of wrapping up in a couple days, and there's been some, we got some interesting feedback already, which is pretty good, and we'll discuss that on Thursday as well, more in detail. So going through our document updates, we've had 2 RFCs since our last meeting, the server cookies 9018, and just the other day, the NSEC TTL. Congratulations, Peter. 9077 has finally sort of been published, and those are both very happy about that. We've got 4 that are sort of sitting in various IEs, either in the editor queue or in the IESG states, and they'll probably like something like Service B may sit there for a little bit because it's sort of sitting on the ESNI draft, which is still kind of hasn't been finished. But those are all, done out of DNSOP, and so our work has been completed on that stage for the most part. There's a couple of things that are coming up that we're talking about today. The IANA consideration, which the chairs feel is really ready for working group last call. The glue is on optional draft, which I'm glad we were able to sort of bring that back from the missing, and we've got a short presentation on that. And we think that with a lot of the sort of work in the past few weeks on that, we're probably ready for working group last call as well, because it's very short and to the point. Same thing with the avoid fragmentation. There's a short presentation today, and we should be able to move that one along. I think there's one thing that sort of was outstanding that I remember that I believe we may have, but other than that, we're in good shape. So we've got a bunch of responses to our poll. So thank you for all that. And it was sort of helpful to help, to sort of see about the prioritization of work. And that was really great. And a little, I wouldn't say surprising, but just, like, oh, that's kind of good to hear from the working group sort of thing. So some of the things that we saw high interest in, which was sort of interesting, was the glue is on optional, which we kind of expected would be sort of a high interesting. The NSEC 3 guidance had a lot of positive feedback. That's going to be talked about later today as well. Also, NS3 validation and the error reporting, they both had some, little higher, and we sort of expected those, and we just sort of were surprised to see a good sort of positive, from folks. So there's something on the private use TLD one, which I'm going to let Suzanne talk about. She spent a lot of time talking with the liaisons and the IAB about this. So I want to say this because whatever I say is going to be just wrong.
Tim, I don't think that's quite true, but just to put down a marker, we are planning to have some more discussion on Thursday if it's needed, but the sort of the update since last time is we had sought guidance from ISO on appropriate use of the ISO 3166 user assigned alpha 2 codes. The liaison manager, the IAB manages liaisons on behalf of the IETF. They put the question to the liaison manager for ISO 3166. We have an assessment of where he thinks the situation is, which we will be forwarding. I ran out of time before the meeting. But we do need to decide what our next steps should be, and we will have a fuller presentation and a little more discussion as needed on Thursday. So thanks. Back to you, Tim.
Okay, thanks. Yep. So that's a good way to sort of put that. Thank you, Suzanne. And, our stuff is in the data tracker in GitHub, so people can look and see what we're up to and sort of comment and give us feedback. We're always welcome to that. Today on some of the current business, NSEC 3 guidance, Wes is going to talk a little bit about that. Schumann's got an update on the glue is not optional. They've been working pretty hard on sort of cleaning some of that up, so we're really glad about that. Mr. Fujiwara-san has an update on avoid fragmentation, and Paul's got some comments about IANA consideration, which we really do want to, the chairs really kind of want to move forward on. We know it's kind of not interesting DNS work, but it's stuff that actually probably needs to get done on sort of the IETF side. Also, Siobhan's going to talk about the domain verification technique stuff. Interesting on an operation sort of point of view, at least from my view of the world. Ulrich's got DNSSEC automation, and then Dan's got the two things on the structured DNS error page bit. And we'll take feedback on that. And I believe, so, and then of course, session 2, we're going to sort of talk about some of the feedback from the poll, and then sort of listen to basically get a lot of feedback from the working group as to what you think we should be working on and how we should sort of order some of the business. We know we have a lot going on. A lot of it, we always let the kind of the working group kind of move stuff, but sometimes that's not always the right thing. And so, because that always lets sort of the louder voices get heard first, and maybe that's not always the right way to go. So let's get started on stuff. We'll keep things on track, and I believe Wes is the first speaker. So Suzanne's going to sort of do some work with the slides here, make this all work. Oh, Benno is okay. So
yes. So Wes, do you want to run the slides yourself via the shared slide desk?
Yeah, that's fine. I think you have to approve screen share.
Yeah, I can approve, but I got with this. Okay, it's fine. So there's a new option also to use directly the PDF from Meet Echo, but that's very convenient.
Where is the presentation button? I'm not muted. Can you hear me?
Yes.
Yeah, I can hear you. Yeah.
I don't see the presentation.
Wes asked to send
Go on screen. No, yes.
There we go. Thank you.
Yeah.
There you go.
Okay.
All right. See it?
Yep.
Okay. So this is about draft IETF DNSOP-NSEC 3 iterations, which is a very short draft by myself and Victor Duchovny. His name's not on the slide. Sorry, Victor. So real quick status on the draft. First off, what's the point? I think probably most people have read it, but essentially we're recommending a few things in it. One, use NSEC if you can instead of NSEC 3. NSEC 3 iterations recommendation in the draft is a 0. So you really shouldn't do iterations beyond 1. It really doesn't help as much as I think we were hoping it would way back when. If you're using an NSEC 3 salt, you should only use it if you're going to change it, because otherwise the salt is pretty much useless. And then for validating resolvers, there's a new proposal for ranges to put into place for what you should consider insecure and things like that. So the range essentially goes from 0 to 100. That's a valid range for NSEC 3 iterations, and you should validate it. From 101 to 500, you should treat it as an insecure zone. And previously, in the original NSEC 3 specifications, those numbers were quite a bit higher, but that caused various problems. And then for 501 above, the current draft, based on guidance from a lot of people in various conversations, was maybe we should actually have a point where you actually return serve fail. And so that's above 500, basically. So in recent changes, these are not in the 0.0 draft. These are on GitHub. They weren't too small to really post, but essentially there's been some minor edits published and a clear guidance separation for zone publishers versus validating resolvers versus a new section on primary and secondary relationships as well, with thanks to Tony Finch and Florian Upser, who gave those suggestions. I'll probably put out a new copy soon, but I really wanted to have this discussion first. So the remaining items to discuss are: one, whether authoritative overhead, how much authoritative overhead requirements are necessary, and how much that hurts authoritative servers. And then the second, to decide if the ranges are right that I had on the previous screen, which I'll reiterate here. Right? Are these an acceptable set of ranges? Or does the working group feel comfortable that this is the right answer? So a lot of data about that. So Victor, in his one-man marching band of contacting every server on the planet that has bad values and convincing them to switch, this is as of yesterday. So he measured a whole bunch of zones, as many as he knows about, that are running NSEC 3 on the internet, looking for their latest set of parameters. So this is a CDF of where the iterations are. And you can see the 100 line is in black there, and the 500 line is in black over here. So you can see that this curve nicely goes up above 90%, as we start approaching 100. If we zoom in, you'll see that actually, if you start looking at this upper right-hand corner, there's a decent amount of zones at 100, but if you remember in my chart, that was an acceptable number. And then if we zoom in even more, you can see that the number of zones at 101 or more is, down into this really, really small percentage of the range. And in fact, if we look at the total number of zones that he actually measured, there were, 11.5 million essentially. The fraction of zones with a iteration value of 100 or less was 0.9994. In other words, 99.94% of zones were less than 100 or 100 or less. And then 5 nines for 500 or less. So it seems to me like, this range of values seems to be accepted. So a lot of various places have come down, and Victor can talk at length about the major providers that have actually, toned down their iterations quite a bit in the last few months due to his pushing and other people's pushing. So given this, and you can see the fractions that fall into the various ranges, they're quite small. My real question to people today, and this is really encouraged to spark discussion, and if we roll over my 10 minutes, we should certainly give it all up. But my question today is, does anybody disagree with these ranges? And if so, we should speak, now we're on the mailing list. With that, that's actually it. This is a very short update, very short document, and we should be getting close to ready to last call if we agree on this. And I see Jim in the queue. Jim? Jim Reed. You should just be able to click if the chairs don't acknowledge your hand. You can turn on your microphone.
Oh, you can hear me.
Yep, go for it.
Cool. I don't disagree with the numbers you've got there, but I would rather we try to do this based on actual measurements rather than a survey of what's the state of NSEC3 deployment today. I mean, it's a useful exercise to gather that data, but I think we probably put some numbers there on the iterations that actually reflect the impact on doing the validation and the load on the validating resolvers because of the iterations that might have to take place. And I think that'd be a better approach there than just saying, well, stick your fingers in the air and say there's hardly any using more than 100 iterations. And if you're over 500, then you're doing something really stupid and then kill it. I mean, I agree with the idea of putting bounds on this stuff. It's a very sensible thing to do. But I would rather we did this from an engineering perspective rather than just doing a survey of existing practice.
That's fair. Then we'll get into the debate of what is the right impact to a validator, and how do we measure that given multiple validators and unknown code ranges and unknown CPUs and acceleration and things like that. So why don't you bring that up on the mailing list? I think that's a great idea to consider doing it, and we need a volunteer to actually do those measurements.
I'll bring it up on the mailing list at least.
Great, awesome, Victor.
Am I there? Yes.
Yep.
So a couple of things to Jim's point. We did have an off-list discussion with a number of folks, right, who are building resolvers and have been making measurements of their impact. They just have to go public with some of the numbers that we were talking about back in April, right? So the folks in NOT and BI and ISC and so on should be able to provide data on that. The other thing I wanted to mention is that steep, spike at 100 will actually mostly disappear in my sense is about a month or two, because TransIP, who's responsible for something like 96 or more % of that 100s, are migrating all of their domains to 0 as recommended. But that's just beginning. So
okay,
the numbers will decline dramatically.
Yeah, the quick point is that
and then we can maybe reassess.
There's a number of people that have been pushing for 25 as a lower bound too, but you can see we're still at like 0.91 of the.
All right. I was thinking 50, right? It gets pretty flat at 50 and up, and if the hundreds are mostly drop to 0, then 50 becomes viable. But we can kind of look at it in a few weeks and see whether things are dramatically better or not.
Okay, cool. Thanks, Ulrich, and then we'll quit.
I wanted to ask you what is, why would you go insecure? I mean, this is DNSSEC signed domains. Why wouldn't you go serve fail immediately?
So there was a lot of discussion on that. The original NSEC3 draft actually says for validators that don't want to support values above, and then they have recommended limits in that draft based on the algorithm. You should treat it as insecure. And in part, I think and I could let the DNSEC3 author speak to it, but it's essentially that in this case the mail must go through type situation where you at least allow the lookups to happen and it becomes not a serve fail. Victor, you want to answer?
Responses.
Your hand.
All right. Security of positive responses. Not many things rely on negative responses being secure, Dane being one of them. But for Dane, if you're out there in the wrong range, we're really doing people a favor by blocking their mail rather than delivering it without Dane when they specify more than 100 iterations. Given how few of them there are, I think insecure is about right. People were concerned that nobody would, however, notice the signal and they would hang out there forever. So serve fail has some merit, but we were reluctant in the earlier discussions to go there. Certainly wouldn't want to break trans IP if we took it below 100 at this point in time. So I don't know. It's open to discussion.
Okay, thanks. Jim, parting shots, and then we're going to turn the time back over to the chairs.
It's just a quick point. If there's going to be some limits set on the number of iterations, maybe that should be encoded in response with a DNS extended error code. So you can actually signal back to the end client that the reason why the validation's not worked out is because the source data's got too many iterations in the NSEC records.
You should read the draft. It's in there. We are sending back an error code. We've asked for one to be reserved in the draft. So, okay, thank you. Back to you, chairs.
Unmuting audio. There you go. All right, I believe Schumann is next to talk about the glue is not optional draft.
Yeah, that's right. Can you hear me okay?
Yep.
All right. Okay, so I'm going to provide an update on the glue is not optional draft. So this was, if you might recall, Mark Andrews' original draft from sometime last year that was adopted, but hadn't seen any updates for a while. So a bunch of other folks whose names you see on this title slide are now also involved, along with Mark, in helping to complete and hopefully push this out. So can you advance the slide? All right, so what did the original draft say? It's stated what glue records are, which are address records for name servers that are contained in the delegated zone. What we're probably going to do is add a specific reference to text in RFC 1034 or the DNS terminology document. And the draft basically says that glue must be returned in referral responses from authoritative servers. And if they don't fit in a UDP response, the server must set the TC or truncated flag, instructing clients that they need to requery over TCP to obtain the complete response. So next slide, please. All right, so the four of us worked out to push out a new revision of the draft that was -01 before the cutoff 2 weeks ago. But there were a few dangling items we didn't get to at the time, which we've now pushed out as -02. That was just a couple of hours ago, actually. So that's the latest version if you're reading it. So a quick summary of the changes from since -00 are that first, the example provided in the original draft of misbehavior by the .gov authoritative name servers, that's actually already been fixed. They now set TC equals 1 appropriately. And so we note that it's historical. We discuss Sibling Glue specifically and what the corresponding processing requirements for such glue are, and I'll get to that in a bit. There's some discussion of cross-zone NS records with circular dependencies, which I think we've taken out in the latest version, but I'll discuss what was there originally. And there's some discussion of orphan glue, which again is a topic worthy of debate, whether it belongs in this draft or not. So let's move on to the next slide. So sibling glue, as far as I can tell, sibling glue is not defined in any IETF document to date. So we provide a definition, and maybe this can be referred to in the next update of DNS terminology. And the definition is that these are glue records that are not contained in the delegated zone itself, that is the zone that the referral is being produced for, but in another delegated zone from the same parent. So in most cases, these aren't strictly required in the referral response for resolution to work. And this is because the resolver can typically make additional queries to resolve the name server addresses and then follow the referral for the sibling zone to get them. However, this causes unnecessary additional traffic from the resolver, and most competent name server implementations we're aware of always provide sibling glue in the response. So next slide, please. And here's a simple example. So we have the name servers for foo.test have glue records that actually live under bar.test. So that's sibling glue from the perspective of foo.test. And if we move to the next slide, we can see that the referral response for foo.test includes the sibling glue from bar.test in the additional section. All right, next slide. So after some discussion amongst the four of us, the main proposal in the draft in terms of processing requirements is that sibling glue must always be provided in the referral response too. And it too is subject to the TC=1 truncation requirement if the glue doesn't fit. And the rationale for that is twofold. It's easier for implementers. They don't have to figure out when sibling glue is or isn't required. And also there's a robustness argument. So we should always try to provide as complete a set of name servers in the response that we can. And if we can't, we truncate. All right, next slide. So in -01 of the draft, we had an example about cross-zone address records with circular dependencies. And by cross-zone, I mean specifically not the same delegating zone or parent. So these can't really be expected to work, at least not reliably. So here we have name server records for example.com that refer to glue in example.net, which in turn refer back to glue in example.com, right? So does that actually work? Or does anybody really expect that to work? So move on to the next slide, please. So we don't expect this to work. I mean, in theory, the zones could arrange to have cross-zone address records returned gratuitously in the referral response. But the question is, why would resolvers actually accept those? This is data from an entirely unrelated zone, not under the purview of the delegating authority. And most resolvers are paranoid about what they accept anyway. So our proposal, when we were discussing this, was to remove this section entirely, which we have now done in -02. But if folks want to push back, we can have a discussion about whether it's worth keeping it in just as a kind of a precautionary example of what not to do. Next slide, please. And there's a small section that talks about quote unquote orphan glue. I just want to note first that this is not really a DNS protocol term. You either have glue or authoritative data. But there are some registries where if a delegation for a child zone is removed and it had glue, then the glue gets promoted to authoritative data in the delegating zone. So normally, I at least would expect that such glue would have been cleaned up and removed when the delegation above it is gone. But in any case, this practice is present in some parts of the DNS ecosystem. So our question for the working group here, I think, is what, if anything, should be said about this practice, right? So one option is we can remove the section. And the other option is if we do say something, probably the least contentious path is to just describe the situation but make no judgments about it. Next slide, please. And lastly, in -02, we've made one additional clarification. So the earlier draft said that glue must be included or truncate, but didn't elaborate on whether that meant all glue or some of the glue or just, one glue. And we now state the requirement is all glue records. So if all of them don't fit, we set the TC flag. And we'd be happy to have a discussion about that specific point if folks don't disagree with it, but that's what we have currently. And I think that's the end of my presentation. Maybe there's one more slide. Yeah, okay, so we have a Git repo for edits to the draft source and for opening issues, etc. And with that, I will stop now and open it up for discussion.
Yeah, we have a few minutes for conversation about this, and actually.
And I think most of my co-authors are here too, so they'll chime in.
Dwayne, I gave. Sorry, Dwayne, you have the mic.
Okay, thanks. I just wanted to reiterate something on the last point that Shuman said about the all glue, because this is different than the way resolvers work today. Sorry, I'm getting an echo. Yeah, so today, I think a lot of authoritative name servers, stuff as much glue as they can, but if there's some that don't fit, they don't set the TC bit. And the draft is proposing something different, which is you always set the TC bit if all glue does not fit.
Jeff, please go ahead.
Through this draft, and I must admit I'm echoing some of the commentary in the chat window about the appearance of what you call sibling glue. You create it as a mandatory, a must, but without any justification. Mike, the draft doesn't really explain why this becomes a mandatory, and yet all other kinds of whether they're in some other indirect level or further afield, aren't described as mandatory. Your presentation said something about optimizing resolver behavior, but surely if the idea is to optimize resolution behavior, you would say all glue. But as you pointed out a bit later on, bringing in all kinds of foreign names as glue creates an authority problem. And so I suppose my major issue here is I'm really not sure that the sibling case is well justified in this document. It's simply asserted without any rationale. And as far as I can see, there is no consistent and obvious rationale to include this so-called sibling glue as a must in this particular draft. So I suppose my observation is either excise section 4 that refers to sibling glue in this draft and just don't discuss it, or you've got to do a much better job at justifying its inclusion and understanding exactly what the trade-offs are in recognizing that it's sibling glue and then making sure that it's mandatory and justifying why that mandatory inclusion is appropriate in all cases. Thank you.
Okay, so I think Mark Andrews is in the queue. I'm going to let Mark talk. Otherwise, I'll answer.
Basically, you can also get delegation loops in sibling glue, which is the reason for it. You don't want to spend the time to determine whether, when returning a referral, whether you've actually got a delegation loop or not, which is why it's mandatory. Does that help you, Jeff?
Take exactly what you said, draft, everyone would be happy, or at least I would be. I don't know about anyone else. But some
Yeah,
kind of optimization was what I was after. Thank you.
Yeah, so Jeff, I agree. We should put that in the draft. I think it was implied in one of my earlier slides, because there are some situations where sibling glue is mandatory. So this actually, if we have one blanket statement, then it's much easier for resolver implementers, because they don't have to figure out, whether it's mandatory or not. They can just, use the same uniform behavior to treat all glue.
Look, I understand that. It's just that if I was an implementer, I'd be scratching my head unless I had looked at your slides right here, right now, etc. I just think one sentence that justifies this would make more sense.
Yeah.
That's all.
Fair critique. Okay, we'll go and do that.
Thank you.
Are you speaking, Ralph?
Well, can people hear me?
Yes.
Okay, great. So I'm echoing a bit of what Jeff said. The sibling glue is really not something that I would like to see a must on, because there are some resolver implementers that will just ignore it. Other will use it, but only in certain cases. They're really, I mean, this also was one of the kind of one of the Kaminsky style attacks, that if you during a referral can use that. If you have more referrals in the additional sections, then you have more chances, and that's why probably some resolvers treated a bit more stricter, and relaxing that I don't think is a good thing to do. And in the other way, if you have a kind of real in-zone glues, make all of them and TC, that's something I'm totally okay with, but not for the sibling glues.
Mm-hmm. Yeah, so Ralph, just to make it clear, we're not, this draft is not imposing any requirements on resolvers. This is just saying what the authoritative behavior should be when they're producing referral responses. So if a resolver implementer wants to be super paranoid and not follow sibling glue, they're still free to do that without violating anything dictated in this draft.
Yeah, but the kind of messages from the authorities get bigger when they have to include the sibling glue, which might not be a problem, but it is more data, so more likely.
It is more data. That's correct.
Okay, thanks.
Yeah, Shuan, you can run the queue yourself if you want.
Oh, okay, yeah, sure, I can do that. So
we have 8 minutes. Okay.
Peter Van Dyke, I think you're next.
Yeah, we should probably cut the queue after John, though.
Yeah.
Thanks.
Glue, I agree with previous speakers. .com and .net hosted on the same servers do not do sibling glue today. And I see no benefit in them doing that. And therefore, I see no benefit in mandating that. The other thing I wanted to say is please add an implementation section.
Right. Okay, so Peter, so the .com, .net glue sharing thing, I think VeriSign doesn't do that anymore, but that's not an example of sibling glue. That's an example of cross-zone glue. I don't even know if you can call it glue, but from different parent zones, right? So the sibling glue definition that we have in the draft is they have to both come from COM or both come from net, not across each other.
Right. Okay. Well, that is good glue.
Yeah.
All right. Thank you.
Sure. All right.
Yep. Hi. So I wanted to come back to the orphan glue, and I think at least you should mention that it's a security risk, because the moment the domain, the actual domain reappears, gets registered again, this becomes kind of a zombie glue that gets into use again. And I think it's at least should we say that it's a security risk to do this, if we don't want to recommend to delete it.
Sure. Yeah, I guess that's a reasonable point. So I guess part of our answer to that question is, do we have agreement on discussing orphan glue in this draft or not, right? So I guess that's a little bit of an open question. So I'm hoping some other folks will chime in on that topic either here or on list somewhere. John Levine, I think you're next.
Is my microphone working today?
Yes.
Oh, good. I am glad you added the bit about returning all of the glue, which is a long-standing bug that has caused some zones to go lame. My inclination would be to take out the sibling glue or make it a maze for sort of based for the political reason that we're going to get some pushback from people on the all glue point, which is really important. And I think I would want to avoid distracting them with the sibling glue, which is basically an optimization. And as far as the orphan glue, that's such a political thing. Like if you are a registry and you know that you've suspended the name and it hasn't been redelegated and the same person might renew it and it might come back, in that case, orphan glue is probably okay, but otherwise it isn't. And I don't see how we can say anything sensible about that in a technical draft other than like, well, don't put in orphan glue unless you're absolutely sure it's still true for reasons that we can't explain.
Right. Yeah, I think I am generally in agreement with you on that, John, too. So, okay, thank you. I think that's the end, right, Benno?
Yep. I don't see anybody else in the queue, and we do need to go ahead anyway. Fujiwara-san is next with the avoid fragmentation draft, which we have discussed before, and the chairs think is getting close to done, but there is at least one significant issue. We want to hear what people have to say. So go ahead, Mr. Fujiwara.
Can you hear me?
We do hear you.
Yes.
Hello, this is Kazunori Fujiwara from JPRS. I will talk about avoid fragmentation 05. Next slide, please. These are updates from IETF111-10. Authors submitted draft IETF DNSOP avoid fragmentation 05, June 23. We moved some text from Introduction to Appendix A, Weakness of IP Fragmentation, and we updated Section 3.3, Default Maximum DNS UDP Payload Size. We couldn't define single value at IETF 110, then authors generated Table 1, Default Maximum DNS UDP Payload Size. And 1400 is set as author's recommendation. And authors moved details to Appendix B, details of maximum DNS UDP payload size discussions, and added new text. Fragmentation avoidance is achieved with the IP.lag, IPv6.lag options. The purpose of packet size limitation is to decrease packet loss due to the effect of IP.lag, IPv6.lag options. And I found that there is a lack of IP.lag definition. So we added a new term, IP.lag, in terminology section. Next slide, please. This is a table 1, default maximum DNS UDP payload size. This table includes, this table contains four recommendation values and one measured. 1220, 1232, 1400, and from Ethernet MTU 1500. Operators may choose a good value from table 1. Next slide, please. We added new term IP.flag. IP.flag option is not defined by any RFCs. It is similar to IPv6.flag option defined in RFC 3542. IP.flag option is used on B3 systems to set the don't fragment bit when sending IP version 4 packets. On Linux systems, this is done via IPMTU discover and IPPMT disk do. Next slide, please. These are current recommendations. Recommendations for UDP requesters. UDP responders should send DNS responses with IP.flag, IPv6.flag options. And fragmentation avoidance is achieved with IP.flag option. The purpose of packet size limitation is to decrease packet loss due to the effect of the IP.flag option. So choose good maximum DNS UDP payload size. And the recommendations for UDP requesters is UDP requesters should send DNS requests with IP.flag, IPv6.flag options, and choose good maximum DNS UDP payload size. Next slide, please. And now, Hayashiriman et al. Published a new paper, DNS over TCP considered vulnerable. They will make a presentation at ANRW 2021 Wednesday. Please check IETF program page. They proposed cache poisoning attacks using spoofed second fragment with valid IP ID checksum and forged payload for DNS over TCP. Their proposed method is that number 1, send IP version 4 fragmentation needed and DF set to intermediate routers between the attack target resolver and authoritative servers. Number 2, send a trigger query to the target resolver. Number 3, estimate IP ID and send spoofed second fragment to the target resolver. The original TCP header that includes source port, sequence number, acknowledgement number exists in the first fragment. Generating spoofed second fragment with the same checksum is easy if the attacker knows fragment size and IP ID. Attack targets may be IP version 4. IP version 6 may not be affected, and their results show that 496 of Alexa top 100,000 domains are vulnerable to fragmentation over TCP attacks. Please listen their presentation and evaluate the effect of fragmentation attack on DNS over TCP. Possible solutions may be RC 6864 updated specification of the IP version 4 ID field and setting IP.flag on IP version 4 for TCP or enable path-empty discovery on IP version 4 TCP. Next slide, please. Authors believe that the draft is ready for working robust code. Please review carefully. That's all. Paul.
Thank you. Paul, please go ahead.
Hi. So On one hand, I appreciate the fact that after IETF 110, that the authors heard the working group by not saying that 1400 was the recommended value. It's just that the authors recommended. On the other hand, this is supposed to be a best current practices document. And if what we say is we don't have a best current practice, that seems weird to call it a best current practices document. So I don't know how to resolve that, but it does seem like a serious problem that we have a very involved document which is called a best current practice, but in fact doesn't have a practice. Thank you.
Victor, please go ahead.
I have a question about the TCP workaround. Is it sufficient to set don't fragment on the resolving client? Because it seems to me that if the large fragment is coming towards the client from the server, even if the server doesn't fragment, maybe the attacker fragments. So I'm not sure how it mitigates the attack. If more detail would be great.
Please listen their researcher's presentation.
Yeah. Okay. So yeah, to the working group. So the presentations is at the ANRW. ANRW. It's on July 28th, Wednesday. It's free for IETF participants. I think you can still register. So if you're interested, all of you can register for the workshop, Advanced Network Research, and listen to the presentation.
Yeah, I've put the URL for the Applied Networking Research Workshop into the chat because that paper had been pointed out to us, and thank you for bringing it up here because it is definitely completely on point. Thanks.
Paul, you have a question.
To that paper on Wednesday, because you can actually look at the early work. Do note that according to the paper itself, that only 0.5% of the resolvers seem to maybe be, I'm sorry, the authoritative servers might be attackable by it. And I didn't have enough time to look at their research results that carefully, but for anything in the DNS, a number that's less than 1% seems mostly in the noise range. Not to say that if it is affecting those, that we shouldn't care, but I'm not sure how much effort we want to put in if it is that, especially since it easily could be that many of those are in fact in front of, load balancer boxes and such like that, which, as we've discovered here, basically never get updated unless something's on fire.
Yeah. Thank you, Paul. I think we're done. Oh, still, Victor, please go ahead. I think this is said, and we close the queue.
Okay, just responding to Paul's, best practice or not comment. To me, it seems somewhat reasonable to recommend a set of choices as all reasonable practices. Each operator can choose the practice that best fits their operating environment, so long as each is accompanied by explanations as to when it is believed to be appropriate.
Yeah, thank you. Thank you for your input.
Yes. Thanks for that. And next, Paul Hoffman, ionic considerations. And I think you're right, this will be quick, but we do need to get it in front of the working group.
Very good. And I'm one of those people who takes up a lot of the slides, so sorry about that. So this is This is basically a repeat of the 110 presentation, so I will go very quickly. Next slide. And then just as a quick status, this was adopted as working group item 2 IETFs ago. It's super short. It's about 1.5 pages of text. There's been very little discussion on the list, which I think is fine. Hopefully that means there is enough agreement. If there is discussion during working group last call, which the chairs just indicated we might be ready for, then that certainly can be incorporated. But at this point, really, there is very little discussion so far. Next. Oh, I wish the bottom of this is actually the most important part. But so the motivations for there are three very different motivations for this. One is we have a draft in front of us in the working group, RFC 5933 bis. It would need to be on standards track if we do not move this draft forwards, because it has, that DS records have to be standards require. But there are many people who disagree with making every single national crypto algorithm need an IETF standard. For one thing, they do not have as much review. We certainly are not good at reviewing the crypto and such like that. And there's a lot of nations who, if they see somebody gets a standard, they might want their own. And that just puts a lot more work on us than if it was RFC required. RFC required, can go through the independent series editor. RFC required, RFC could actually come through the CFRG. So having to put it on standards track is a lot of overhead. But the second very important thing is that we're not just talking about doing this for this one document for RFC 5933 bis. Quantum resistant signing algorithms are a new shiny thing in the crypto world. What is more shiny at the moment is quantum resistant encryption algorithms, but there are a bunch of signing algorithms with lots of different properties. And because the focus is mostly on encrypting algorithms right now, NIST is proposing to have multiple algorithms that they might say are acceptable for quantum resistant signing. The theory in that is that there is not necessarily as much of a one-to-one correlation for quantum resistant algorithms between signing and encrypting. It's not like you've got your RSA, which you can use for encrypting, and therefore you can use it for signing. You got your ECD, you got your elliptic curve, which you can use for both. There's lots of different tweaks in all of them. So we could see literally 5 quantum resistant signing algorithms before the world comes together on one. And so having to put each of them on standards track would be very confusing to the world. Next slide. So the reason why we're doing this draft is RFC 6014, which was standardized in 2010, made all of the new DNSSEC registries RFC required, but it forgot to backport DS and NSEC records. So all the new ones were RFC required, but we left 2 of them out. And there was no justification for the difference. And in case anyone's thinking that I'm being mean about the author of RFC 6014, that was me. I mean, maybe I'm being mean on myself, but we just missed it. It's okay. We can fix this now. And then also in RFC 8624, which this working group just recently did, we talked about GOS being May, but we don't talk about any other national algorithms either, that might come down the line. So that's what we've got before. Next slide, which is the last slide. So what this draft does is simply updates RFC 6014 to make all of the algorithms RFC required. So that all of the RR types are the same, and that will update RFC 8624 to automatically make any of these non-standards track algorithms may implement. Yeah, that's it. That's just essentially let's regularize things. So that's it for my presentation. If there's questions, great. But if not, I agree with the chairs. This is ready for working group last call. And certainly things can come up during working group last call.
Yeah, just to sort of amplify on that, registry policy for reserved flags and fields is one of the more arcane things we deal with, and arguably one of the less interesting, but it does have long-reaching effects. So any thoughts on how this will scale into the future? That's the important thing, to make sure that registry policy drafts get reviewed. So if you haven't looked at it, take a look at it. But we would like to advance it.
Yep, Victor?
GOST, the current GOST that we have is already long obsolete in the actual nation. I believe Dmitry Bilatsky was going to work on a new one at some point, but the old one should be gone by now, because they don't even do it anymore.
Well, but it's not, and that's why we have the BIS document in the working group.
Right.
Yeah. Yeah, so they're waiting for this document, the GOST2 algorithm draft. Yeah.
All right, I don't see anybody else.
Thanks very much.
Yeah, that's it. That sounds like folks should go ahead and review this. Next up, the domain verification techniques draft, and I believe Shuman is presenting that one also. Is that correct?
It's I'll present Shuman, if you can hear me.
Yep.
Okay, sweet. Should I say next slide, or should I present slides? Okay. Sorry, if you wouldn't mind just going back to the beginning.
Yeah, you're free to present the slides yourself, whatever you prefer.
Okay, let me just try that quickly.
Yeah. I'll ground. There you are. Sorry, I will grant you slides. Excellent.
Okay, great. So, hi all, I'm Siobhan, and Shuman and I wrote a draft, relatively new draft on domain verification techniques. We did a survey and we had some recommendations, and yeah, it's a pretty early draft, so just curious what folks think. And yeah, we had some questions at the end of the presentation for the working group. So first question was domain verification. And as you might expect, so many providers on the internet use domain verification in order for to let users kind of prove that they control a particular domain before granting them some kind of access or some kind of privilege associated with that domain. A good example is Let's Encrypt. You might have if you're requesting a certificate, they will ask you to prove that you control that domain by asking you to put a DNS text record or something, and if you can do that, you prove that you have control over the domain, and then you are issued a certificate for it. They also have an HTTP based challenge, but for the purposes of this draft and this presentation, we solely focus on DNS challenges and DNS domain verification techniques. So yeah, the first part of the draft kind of focuses on like a survey of existing techniques, and by and large, an overwhelming majority of service providers use text-based verification. So essentially, please add this DNS text record with a random value at the domain being verified, and that if you can do that, that proves that you own this domain. There's a lot of variation in how clear the requirements are, what the expiry policy is, which is not ideal. But there's a couple of different patterns that folks use. So one pattern is our data, and this is pretty common. So you'll have like a key value pair. So on the left side, on the key, you'll have the service provider, and the value would be the random value being put up. So RFC 1464 kind of specifies how you can use key value pairs in the text RData. This is a really common pattern that service providers use. Another way of doing this is putting a label to the left of the domain you're verifying. So, Let's Encrypt does this, and so does GitHub. So you kind of say, underscore service provider dash challenge dot the domain you're verifying, and then under that label you put like a random value. And so RFC 8555 actually has really clear requirements about what about the random value, and also extremely clear about when can it be deleted. GitHub is also extremely clear, like it's a 7-day expiry on the random value. You have to wait for 72 hours, and then you can delete it. I think these are good examples, and we kind of go into this in the recommendations part as well. So another example is just when folks don't add any kind of information to the DNS like verifying record. So it's just a random value, random text value. And CNAME, so apart from text-based, there's also CNAME-based ways of doing domain verification, and this is often a fallback option. So it might be used if the domain name, for example, already has a CNAME, and since CNAMEs can't coexist with other records, so this is like a fallback option. And in this, you point to a service provider property. So if you take a look at an example, you put a random value to the left of your domain, and then you point that via CNAME to like again like a random value dot of the service provider that you're trying to verify, that you're trying to get verified on. So this is like kind of like I mentioned, like it's a fallback option of the text record option, but it's not as common. Not everyone supports it. So that kind of is like the survey that we did, and we have some examples in the draft as well, and we want to add more, but we also go into recommendations, and I think the most important one is targeted domain verification. This is basically what Let's Encrypt and GitHub already do, where you put a label to the left of it, and you can and via like an underscore label, and it basically allows the service provider to get only the records that they need. Because the issue is that, I think I'll put an example, if you do like digcnn.com for text records, I mean, it's a pretty huge response that you get back, and that's not uncommon. So essentially, putting all text records at the same name can cause bloating, which can cause retries over TCP, which is not ideal. So the second thing that is also important is time-bound checking, or basically guidance on what the expiry is, or when the text records can be, or CNAME records can be deleted. They're often, like anecdotally, we've seen at least one case where, like a corporation or enterprise actually lost access to the servers they were paying for because they were going through a cleanup process and deleting old text records, and they thought that, oh, it's already verified, so we can delete it. But it turns out that that domain was being continuously checked for, so that caused a little bit of an outage. And this seems to be quite common. So our recommendation is that the service provider should be extremely clear about when the DNS record that is doing the verification can be deleted. And we also talk about whether it's advisable for the records to exist in perpetuity, because some service providers do recommend that, but we couldn't really find any reasoning or rationale or security guarantee that comes from that. So so we actually kind of say that there's no need for it to be just to exist forever, and you should probably say that you can delete it in like a certain after the verification is done, essentially. And we also talk about DNSSEC, and we say that DNSSEC should be used to prevent spoofing attacks. Domain owners should sign their zones, and a verifier should check that that the DNSSEC validates. So this is kind of what we have in the draft right now, and some feedback we've gotten has been that if there's no DNSSEC, then maybe another way of doing validation could be using multiple vantage points, which is actually done right now by Let's Encrypt, and they have a paper on this. It sounds like a good idea. One thing to think about is, should there be an IANA registry for underscore prefixes? So in the Let's Encrypt example, there's an underscore acme challenge. So should you have like a reserved keyword over there so as to prevent collisions? Yeah, that's an idea. Thirdly, like we also do, verify should kind of make sure that they should not accept a request to verify a domain at or above a public suffix boundary for security reasons. So they should be mindful of that. And we couldn't really find an example of a service provider that doesn't conform with this, but it just seems like that should be there. So another important thing to keep in mind is the domain verification just for the domain or for everything underneath? So I think, for example, Google Webmaster Tools is for everything underneath, but like all subdomains underneath the domain that you're verifying, but something like Let's Encrypt would be just for that domain. And lastly, like, do we need a new ARA type for this? It's probably controversial and probably would not be in this draft, which kind of leads us into the next slide, which is, does the working group want to adopt this draft? And would it be informational, which is kind of how we're pitching it right now, as a survey and some recommendations, and yeah, other topics of this draft that folks would like this draft to discuss. And yeah, that's about it. And I'll leave the slide up.
And Victor, go ahead.
Sure. There's a sort of somewhat obvious man-in-the-middle attack here. That if when a challenging you to publish something is malicious, then they could in fact be man-in-the-middling a challenge from yet another provider that is important to you, and getting you to publish something that somebody challenged them with, and then taking over your domain essentially for something you didn't anticipate. How do we scope these things properly so that when GitHub challenges me, they're not acquiring a Google verification token or something else that they shouldn't be challenging me to publish? Has that been considered?
No, would you mind just quickly describing that attack again? So you're saying that GitHub would, or like as an example.
Suppose GitHub wants to take over my domain for convincing Google that they control my domain.
Mm-hmm.
I go sign up for some GitHub service and they give me a challenge, and I publish the challenge they asked me to publish, but it's in fact a Google challenge to GitHub that they replayed to me. And then I publish it, and now they own my domain as far as Google is concerned.
Mm-hmm.
This perhaps somewhat unlikely in most cases, but I think it's a real issue potentially. How much do I trust my challengers to not replay challenges from somebody else?
Mm-hmm. That's interesting. We hadn't considered that part of our threat model, but I guess like having a registry and we kind of I don't know if there's any way. I don't know if you should be relying on users to verify that, oh, GitHub should only be able to check, putting this this underscore prefix names. So
maybe the challenger's domain name should be somehow built into the way that it's published or something. But I think it should at least be discussed, even if you don't have a solution. It's certainly something to be aware of, that there's a man-in-the-middle issue in this protocol.
Mm-hmm. Yeah.
Okay. Don, go ahead.
Some tricky security things, but I wanted to mention, you say maybe there should be a direct IANA registry for underscore names. There is. It's called the Underscored and Globally Scoped DNS Node Names Registry, and it currently exists.
Yeah, I guess we meant like specifically using that for this use case. Yeah.
Okay. Ben?
Hi, Ben Schwartz. I support this. I think it's worth adopting. I do think that it merits a lot more security attention. I think it'd be interesting to really have some security review from security experts here. There's a few different things I can think of that stick out. One of them is that some of these challenges, most of them currently, I guess, allow the validator to require the customer to put arbitrary data in their zone, which means if there's some sort of intermediate entity with a parsing bug, the validator can craft arbitrary RR data that might trigger that bug. There's also inter-RR data confusion, as somebody else just pointed out. So if the thing that I'm getting is supposed to be an opaque token, but it's actually structured as a key equals value pair, then it could match one of the other validation patterns and cause me to validate my underscore prefix domain as if that entire domain, including the underscore prefix, was the domain that I'm validating. There are some attacks that only work if the Q name is predictable, and so some of these forms have predictable Q names and some don't. I think that merits analysis. So, but I support this. I think we can work through all of that.
Yeah, so our plan was to take it to get some security review and do some also reviews from our area. Yeah, definitely agree that we would want to kind of think through all of the scenarios here.
Okay. Anybody else? I'm not seeing anybody in the queue. So I think we're still in the gathering feedback phase here. If folks have not read the draft and are interested, please do, and comment to the mailing list, and we will see where the interest goes. Thanks very much. And Ulrich, I believe you're next, the DNSSEC automation draft.
Okay. Benno, are you sharing the slides?
Yes, I will. Thanks. Oh, I found it. There it is.
Great. Hello, I'm Ulrich from the Swedish Internet Foundation. And this is a joint work with Schumann and Steve Crocker, Eric Osterweil, and a few other people. And we have presented the multi-signer document in the last IETF, and this is a short update. Next slide, please. So we have been busy testing. And so what we have done is to list the capabilities that we need for multi-signer to work, and which is basically add DNS keys, remove DNS keys, where the server actually doesn't have access to the private part, and then add and remove CDS or CDNS key records, and lastly the csync records. And so we tested this with different softwares, and we tested this on the command line with the dynamic DNS and with the REST API. And some of this is okay when there's a bind and don't have a REST API. So of course this is no. But and then we had a discussion with Matthias about bind, that he was able to do some stuff with bind that we weren't able to do. So we have to figure this out. But we can say this worked with PowerDNS already. And so next slide, please. So we moved on to some DNS service providers. And so DESEG.io is actually supporting this. And I got the confirmation this week that they actually now support the csync records too. So and I come back to this a little bit later. So we are in talks to NS1 and Newstar to implement this. And if you are responsible for any other DNS provider, we would be happy to talk to you and run some tests. So please contact me by email or some other way, and we see what we can do. Okay, next slide, please. Yes, so we have what we have done in the last months is we tested the algorithm, and that actually works. We have in some steps there's some workarounds needed. Sometimes you have to import the KSK also. It's not really necessary, but you do what you have to do to make it work. And what we have not tested yet is the key rollover or the algorithm rollover. That is something that we still need to do. Next slide, please. Yes. So and then additionally, we have done an implementation. We have implemented a controller that actually runs the whole algorithm, and it supports dynamic updates with PowerDNS and with the DE-seg REST API. And it is under active development. And yeah, we would be happy to implement other interfaces to other service providers, so authoritative server software. And then the next slide, please. Yes, so, and then we have the draft. There's the link to GitHub where we work on it. It's a work in progress, obviously. We have done some clarifications and wording and added explanations to what all this is, to be more specific. We added the algorithm for the key rollovers, and actually also for the algorithm rollover. And then I added the section about explaining why all signers need to have a common set of algorithms they support. And yes, and we would like to ask the working group if this is something that the working group could, work on, adopt, and in that case, what status the document should have. And with that, I'm open for questions. And I think we start with Brian.
GoDaddy is definitely interested in supporting the multi-signer. We're also advocates of supporting CDS, CDNS key via the registrar, where the registrar polls the registrants and then submits through EPP to the registry. And there's another proposal, which is the bootstrap proposal, that we're going to also be advocating for advancement of. And I think that ties in on the multi-signer as a way of bringing the second provider or second and third or whatever for the purposes of getting the DS record at the parent.
Yes, yes. I think there is actually, we discussed this in the last week. I was on vacation, I didn't discuss it, but I've seen that. But there was a discussion about currently in the draft, it says the signers need to establish trust. And that's of course easily written, but harder done. And so we think that the bootstrap might be a way to establish the initial trust between signers. Yes. Yeah. Great. Yeah.
Okay.
Schumann.
Okay. How do I enter the queue? All right. I'm in. So I just wanted to provide some information. The Bootstrap document that Brian and you were talking about, this is Peter Thomas' DNSSEC Bootstrap document, right? I don't think I've seen any discussion about that on the mailing list yet, but I think it's an interesting idea and we should discuss it in more detail. Just a general comment to the community.
Absolutely.
Yeah, not seeing anybody else in the queue. This is Suzanne. No hats. this draft and this algorithm look like they're not going to be trivial to implement. And this also looks like the sort of thing where we do want to have multiple interoperating implementations, at least on the horizon, if we want to advance it. Just because, well, because DNSSEC, among other things, but certainly any security sensitive undertaking like this. So do you have a timeline for having reasonably complete implementations?
Well, so I mean, it works with PowerDNS, and we are currently working with Matthias from ISC to make it all work in bind.
Okay, so the answer to the question is soon. That is good.
Yes, yes. And I mean, I would guess that we would like to have, you know, we have the ESEC, but they use PowerDNS in the background. Maybe some, you know, more independent service provider would be good to have on board. So, I mean, NS1 New Star probably can provide this, and we are in Schumann is actually talking to them, and we hope that they will have an implementation by the next IETF.
Fabulous. I am looking at the implementation section in the draft to sort of refresh my memory. And that all seems good.
So Suzanne, I think you're right. It does look complicated, but I think it's implementable. As we've shown, we already have it working with one. We don't really expect any problems. It has to be implemented carefully, but we think it can be done.
My past sins as a software engineering manager are showing.
No, I totally agree. But actually, I think that complexity is the argument to automating it.
Yes.
I don't disagree with that. Totally on that. Okay, anybody else? I'm not seeing anybody else. So next up, I think Tiramal, and I'm probably not getting your name right, apologies. Tiramal ready on the...
I'm going to do the presentation, if Benno can
I'm sorry?
show the slides.
Oh, Dan,
This
yeah,
is Dan
okay.
Wayne. Yeah, because it's 3 a.m. at Tiru's house, and he's heading out.
Okay.
Totally support that. And I just want to shout out to Benno for being such a trooper.
Yeah, this is awesome.
Thank you. Okay. The first is structured or the other, then?
Either one, whatever you'd like to do. Let's do let's do the unstructured one,
Okay,
for lack of a better name first. Sorry.
Okay. Yeah, here it is.
Awesome.
Okay, so the one that's last on the agenda, but we're swapping them. Cool.
No, they're not being swapped. So these are in the same order that the agenda was that I looked at least. The structured was very, very last, which is
yeah,
what this is.
correct.
All right, my mistake. Sorry. Go ahead.
No worries. I just wanted to clarify for the audio and whatever. Next slide, please. So we just have some changes from feedback that we got from the working group at the last presentation. The big question was how to mitigate forgery of the eDNS 0 that's sent back. So next slide. So a little background on what we're sending here is a URI template that comes back in eDNS 0, and it's how to prevent that URI template from being some bogus thing pointing off to Never Never Land or pointing off to some victim or something scary in those sorts of categories. Next slide, please. So the mitigation we added was the FQDN of the eDNS 0 option. So what's in that URI needs to match the FQDN of the DOH-DOT server that you're connected to. So the names need to match. We expect the certificates are going to be different because one's an HTTP server, the other is a DOT server, for example. If they're both, if it's DOH, there's a higher likelihood. But instead of worrying about certificates and all that stuff, was just an FQDN comparison, and of course, a successful TLS handshake with that host, and that was it. The other second bullet is kind of a nice side effect of this check is that by doing this check, we also notice that a non-supporting DNS server, so forwarder, was seeing this EDNS0 option and was forwarding it from somewhere else, and it shouldn't have. And you can detect that with this by doing this check as a nice, handy side effect. Next slide. That's really about it. The other was, to make all this work is strict privacy profile, but I think that one came out of the discussion anyway. We just added the text for that. Next slide. And I think that was it. So that's it for this presentation. Are there any questions?
Yes, Ben, please go ahead.
Hi. So I feel like there's some feedback that has been missed in this discussion, which is that this draft is specifically aimed at browsers, but there's been no expressed implementation interest from browsers. So, and that's not, because it's been overlooked. That's because the browser experts who have participated have raised a series of serious technical and security concerns with this approach. So I don't support adoption. I think that if we wanted to move forward with this, we would need to see some actual client-side interest and some changes to the draft that make it appealing to implement in that context.
That's fair, and I appreciate that feedback, and that's what the next draft and the next presentation we hope resolves.
Yeah. Okay. Any other questions? Otherwise, I go to the next presentation.
Yeah, let's jump to the next one.
Yep. Okay.
Because of feedback like that, I wrote a different way of solving the same problem. And as soon as the deck comes up, but it's basically the same idea, but instead of returning an HTML page, we return JSON. Next slide, please. Right now, it's currently structured as a companion to the previous document. Obviously, we can move text around as necessary, but what this is parsable JSON, and the client logs it or displays it or does whatever it wants, complains to a greater authority once it receives that JSON to figure out what to do instead of showing it to the user. Probably a better solution for headless. Next slide, please. And the mechanism that is in this draft with JSON also allows multiple filters for different reasons or for the same reason, filtering different things. But the example here that I built for the slide deck was if there's some commercial DNS filter doing court-ordered filtering or government-ordered filtering for pornography or whatever, and then there's an IT-operated filter that's filtering for malware because they have a different interests than what your federal court wants to do or your federal government wants to do. Both of those can indicate that they are the ones that filtered and why they filtered, and provide all the feedback information either all the way to the client, or also allow the IT operator to basically rewrite that effectively by proxying that effectively in order that the client get enough information to complain to IT, and that IT have enough information to understand which commercial DNS filter decided to filter the data and why they decided to filter the data in order to chase back false positives that may have happened with the filtering. Next slide, please. And this is an example of the JSON that comes back. What's bolded is just to help with the seeing this on the slide, but a list of URIs to complain to. Those can be anything, so mail tos, HTTPs. I threw in tell URIs for fun. Justification, following the HTTP language preferences is what we intend for the language to come back for the justification text. And then the name of the friendly name of the filtering service, and then if they want, they can point to the regulation or the HR pamphlet page number if it's done by IT or whatever for why this was filtered. the idea is to hopefully reduce the calls coming back into IT or coming back into that commercial DNS filter operator for being overly zealous in their filtering. Next slide, please. And some of the deployment considerations that are in here, and actually also in the other draft that I presented previously, is that filtering changes, and this is one of the subtleties, is that just saying it was broke, the user might figure that out a couple of minutes later and might complain to IT a half an hour later because it takes that long to open a ticket. And then IT looks at it, 12 hours later. By then, the filtering is cleared and it's gone, and the user just gets frustrated with why that happened. And then it gets filtered again 7 days later, and all sorts of fun stuff like that. So there's some encouragement text in there that there's enough information to allow IT and to allow that upstream filter operator to trace back to why were we filtering it back when we filtered it, even though we no longer are, or we've changed the category of the filter, or we've changed, how severe that this customer is getting filtered versus another customer. All the reasons that these filters change is to provide that in the URI or in a sequence number or in a database or something. How that's done is out of scope because the protocol doesn't care, but it's necessary for user satisfaction. Next slide, please. And that's about it. There's one comment from Ecker on the list that was positive on this draft. I'm not aware of anyone else reading it, which is why I was interested in presenting it. So certainly like to hear feedback on the list or hear feedback here in the meeting.
Okay, thank you, Dan. Ben, please go ahead.
Hi. So I do think this is an improvement. I still have some concerns about this. One of them is that you have URIs, you have HTTP URLs in your JSON structure, and you also have a name. The name is not authenticated in any way. The HTTP URLs are not really constrained in how they're opened or anything like that. And so I think if this were actually displayed to users, I think there's, again, a real potential for misuse where where somebody puts in a response that claims to be somebody they're not, and redirects the user to a page that looks like something that it's not.
Agreed. Okay.
I would be more comfortable if there were not HTTP URLs there, or if we were just clearer that this is in fact strictly machine readable and not intended to be shown to users, because I think that's really where its utility is.
Okay, gotcha. I see what you're saying. Okay.
I would like to see this. I would like to see some amount of harmonizing this with HTTP 451.
Okay.
Which already addresses some of these issues and has its own tiny taxonomy for describing some of this kind of stuff. So I'd suggest taking a look there. Also, I think that as a technical matter, the indirection through HTTP that integrates this into error page is complicated and unnecessary. It means that you can't make use of this unless you have an HTTP stack in your client. So a DNS over TLS client that only does DNS over TLS is kind of stuck unless it links in a whole HTTP library to go fetch this thing. And there's kind of no reason why it's not like we're going to have megabytes of JSON here. So there's no reason we can't just stuff it into the DNS response.
Yeah, our reason to avoid that to date has been a difficulty in standardizing what these error codes might be, because porn for me is different than porn for you, and malware for me is different from malware for you, and categorizing those things into something that is a letter or a 3-digit code or something seems too hard.
Yeah, absolutely. I don't want the IETF to be in the business of trying to categorize all of the things that people don't like. I just want us to be cautious about how we convey that information to avoid opening up more avenues for abuse.
Okay.
And finally, I'll just say that some of the language here normalizes the use of DNS response forgery for censorship of the internet, and that's personally not acceptable to me. I think we need to be very careful about how we talk about these issues, because there are people who are going to twist our words to justify all kinds of strange policy decisions.
Okay.
Yeah, just as a point of order before we go ahead with the queue, this is Suzanne. We have time, a little bit more than we anticipated, and this set of documents does touch on a bunch of things that we've talked about before and found challenging. So folks should feel free to comment. Thanks.
Victor, please go ahead.
Quick comment. The JSON that I saw looked fairly large-ish. And when we're returning errors, I think there's good reason to try and make the responses as compact as possible so that we don't have errors receiving the errors. So less is more here.
Okay.
The other question I have is some resolvers are now receiving or doing DOE on behalf of the user, but then are in fact iterative resolvers, unbound and the like. And the question is, there should be some discussion of whether such errors are expected to be cached and forwarded end to end, and then the user should be seeing them in the response from the caching resolver, or whether they're only for the cases where the application is making the queries directly. But the other case also happens.
Okay. We can clarify some text around that. I'm not sure the best way to approach that offhand. Okay. I took a note.
Okay. Thanks. Warren, you're next.
Thank you. So 2 things. Firstly, I think that we really need to make sure that this is coordinated or at least discussed in places like SecDispatch and TLS. I think I mentioned that last time. I mean, this one, not really quite as much TLS, but I think that we need to be very careful that there is cross-area review. And then with no hats, I think we also need to be fairly careful that this doesn't sort of normalize the idea of DNS filtering. Okay. If we create this, I think it's going to be fairly easy for people to point at, the IETF says that this is a fine thing to do. They've even created a protocol to do it. So therefore, ISPs, providers, etc., should go off and do DNS filtering. That's all.
Okay.
Vittorio, sorry. Please go ahead.
Yeah, okay. Well, first of all, I think this is a better approach than the original one. I think that a structured set of data can bring in more clients. So this isn't just appealing for browsers. I mean, at least if it is, this could be easily used by IoT network stacks or by security apps run by corporate security vendors. So I think it's, I like this more than the earliest one. And I approached my colleague who is a co-author, also asking, well, why are you still using this layer of indirection? I think it would just be easier to stuff the JSON, or at least the key parts of the JSON into the EDNS response. And in this way, you could, avoid having to implement an HTTP stack in the client, and also the entire mechanism would be easy, and you would offer less surface for attacks. So I second also the comment that Ben Schwartz was making. I think we could just adopt this and maybe work on the problematic aspects, for example, in terms of ontology. Yes, definitely we don't want to decide what is porn or not, but we could just leave hooks for people to have pointers to their ontology if they feel the need of. So, I think that these are problems that we can address, or at least that are worth discussing more in a working group discussion if we adopt this. these documents. And in terms of normalizing DNS filters, I think that we will possibly never get to agreement whether, I mean, that there's people that think that DNS filter is the best thing ever invented, and other people think it's really horrible. I think we just need to make it work better for the people that need to use it, because it's mandated in certain environments or in certain countries or so. And I don't think the IETF can make it go away.
Okay, thank you.
Okay. Jonathan, you're next.
Hey, John Reed, Akamai. I agree with that. I would like to see us adopt this and work on any concerns. In particular, I think you could minimize the response by possibly even avoiding the reason for the categorization, because at the end of the day, it doesn't really matter. What matters is to get a clear signal that, yes, this was intentionally blocked, and here's who to go call to fix it. And I think providing that clear data in a structured manner is incredibly valuable, particularly to operators. You know, again, we can continue to have a debate about whether or not DNS should be a control plane. The reality is it is. And it's a service that many people have explicitly opted into in the ISP market. You know, setting aside enterprises and schools, there are people who have paid money to their ISPs to say, yes, I want this feature. And I don't think it's right for us to say, well, you know, we don't agree with it, so we're not going to legitimize it or normalize it. So I'd like to see us adopt this and work on some of these concerns. I think there's a path forward here.
Okay, thank you.
Thanks.
Okay. Next, Joey.
I pretty much agree with what Mr. Reed was saying. I also think that adopting this draft will help to get a lot of people like working together towards these concerns, specifically the security concerns that Ben mentioned, getting a move on how to prevent this from potentially being misused. And at the same time, also agreeing with what Reed said, I also fail to see how providing legitimate information on cases where content has been censored or blocked. I also fail to see how that normalizes censorship itself. I actually think it's actually quite the opposite. I think that promoting or giving access to information that allows users to have an informed choice of the services that they are subscribing to or that they are paying or whatever, and empowering that informed consent actually works against those concerns. I mean, I actually see that as a positive point of view instead of the negative one, if that makes sense.
Okay, cool, thanks.
If I continue the trend of agreement, I completely agree with Jonathan, Vittorio, and Joey. This is a positive development from a sort of user experience perspective. Should absolutely be encouraged, and it'll be fantastic to see it adopted by the working group and further progress made. So yeah, I don't see the downsides. More transparency, better user experience, all of which seems like the right thing to do.
Thanks.
So this is Paul Hoffman. The DNS world sometimes forgets that other people have considered some of the issues that we are considering. We are 25 years into trying to standardize web error response pages. Go through the HTTP working group mailing list probably every 3 years or so, and you will see massive failures there. Even just for, as was mentioned earlier, the error 451 discussion was exceptionally heated. Not heated as in should we or should we not, but even among the people who said we should, how to slice and dice it. I can't disagree more than with Andrew saying this should be pretty easy. This is not easy. It absolutely involves a lot of trade-offs. It certainly involves a lot of trying to balance the understanding of the people who are doing the blocking or filtering or whatever against the users. Users inherently don't understand this. That's why we're discussing this at all. If this is adopted, I would suggest it actually not be adopted in DNSOP, other than the fact that we're still, a zillion drafts behind anyways. I would say this would absolutely need to be a standalone group with a lot of non-DNS people who have worked with user experience, and also people like Andrew who work with service providers, the ones who would be doing the filtering and such. If we do this in a simple fashion, we will fail miserably, and we will still have a protocol out there that people will use badly.
Okay.
As usual, RAD gets the last one. Warren?
I guess just want to kind of carry on from what Paul said. I think that this does need a much larger set of discussions. I mean, looking back at things like the discussions around pervasive monitoring and the error code 451, etc., I think it has a fairly large amount of similar sort of stuff. I agree that it would be great for users to know why they might not be able to reach a set of sites, or that DNS censorship is in place. But we also need to strongly consider if this sends the message that the IETF believes that using the DNS to censor stuff is a reasonable solution. And I think there's going to be a significant number of people in the wider IETF that will view this as, this might exist, but documenting and saying exactly how you should go ahead and use it is going to be viewed by the wider world, the press, etc., as the IETF endorses censorship. It also, I think, potentially creates a attractive nuisance once there's a set of documents explaining how you signal this. I think it becomes very easy for governments, etc., to say, there is a well-known way to do this. It's blessed by the IETF. Just go do this and send this code. So I think just sort of more warning, be careful, wider discussion needed. And again, that was, no hats.
Okay. Thank you.
Yeah, I think we've had that tension before between whether documenting something implies endorsement necessarily, or that is something we can reasonably do in order to promote caution and allow non-consenting adults a way out of doing things they don't want to do. We've been through that with previous drafts, some of which became RFCs, some of which did not. But yeah, that's an important aspect of things. I'm looking and I don't see anybody in the queue, and so we figure. And here's Andrew. Go ahead.
Sorry, yeah, just to bring to the queue what I put in the chat, which is I don't think it's helpful to use pejorative terms like DNS censorship. Things like content filtering to block malware are well-established mechanisms. There are plenty of geographic markets where the majority of users voluntarily opt in to DNS filtering for services like malware filtering, for parental controls, and so on. I think we just need to face facts, and that this exists, and surely it's useful for the user experience to actually provide meaningful information. And as Joey has observed, more transparency actually makes it harder for the more sort of badly intended sort of censorship type activities. So let's bring this out into the open rather than just completely unhelpful user experience that happens currently.
Thank you. I think Warren and Paul also were right as far as applying a lot of thought to whether we want to consider this and whether DNSOP is the right place, and how to make sure that we get the cross-area review we need. So the chairs will be discussing that, and we'll take it to the mailing list. I think my co-chairs are done with their comments, so we are So we are, I think, done for the session, for DNSOP session 1 for IETF 11. We can give everybody 10 minutes back of your day. We have another session in the last session on Thursday, 16:30 to 17:30 UTC. And we will be discussing some of the prioritization things and the polling that we've done as far as managing the working group workload. So see you then, and thanks very much for your time today.
Paul has raised his hand.
Ah, okay.
I had my hand. I thought we were going to have an all other business here. Quick question on the chair slides. When you were talking about the SVCB draft having moved out of the work group into the IETF, and then you said, well, but we're waiting on ESNI. I wanted to be sure that in fact, oh, good, Warren has his hand up. He can probably answer this then. I wanted to be sure that the SVCB draft would move through the process all the way to the RFC editor and then wait for ESNI, that we are not blocking on it going to the IESG.
Nope, I believe that that's correct. It was sent to me a few days ago. I have finished writing up my notes, but I haven't sent them yet. And it will go through IETF last call, ISG eval, etc. It'll just get stuck with the RFC editor.
Very good. Just wanted to make sure that that was the case, that we weren't trying to do some waiting on, given that the TLS working group doesn't even have it in working group last call. I would like to see it, since the ESNI stuff is not a major part of it, I would like to see implementation be able to move forwards without it. Thanks.
Thank you. And I guess that's it. Except, Paul, are you back in the queue? Guess not. Okay.
By clicking my mute button too many times, sorry.
Okay, no worries. But I think we are done for now, and we will see at least some of you on Thursday. Thanks very much for your time.
Buddy. Later.
Bye-bye.